All right, let's talk about one of the most practical design patterns you'll ever use in Go, the factory method. We're going to see how this simple idea helps you build code that's way easier to change and maintain, and it all starts by asking a kind of weird question.
So here it is. When should your code not know what it's creating? I know it sounds a little backward, right? But embracing this idea, well, that's the secret to unlocking software that doesn't break every time you need to add something new. Let's look at a super common problem to see exactly why. Okay, picture this. You're building a checkout service. Right now, it handles cash and credit cards. Easy enough. But then the business comes along and says, hey, we need to add Apple Pay. Now you've got to crack open that core checkout logic and mess with it. Every single time a new payment type comes along, you're forced to modify stable working code. That's what we call tight coupling. And trust me, it's where bugs love to hide. And this visual just says it all. Look at the left side. The checkout service is a tangled mess, with wires going directly to every single payment type. But on the right, so much cleaner. The checkout service only talks to one thing, the payment factory. The factory becomes this neat little middleman, hiding all the messy details of which payment object to create and when.
So, how does this factory actually work its magic? Before we even look at a line of code, let's use a really simple analogy that'll make it all click. Just think about a trip agency.
You know, when you book a vacation, you don't call the airline, then the hotel, then the rental car company yourself, right? No way. You just call the trip agency, that's your factory. You ask for a trip, that's the general idea, the interface. The agency is the one that deals with all the specific details, the concrete things like Delta Airlines or the Marriott Hotel. And here's the key. If they decide to switch you from the Marriott to the Hilton, do you care? Nope. Your trip is exactly the same. The agency handled the change for you.
Okay, analogy makes sense. Now, let's see what that trip agency looks like in actual Go code. It really boils down to three main pieces, three pillars that all work together perfectly. Pillar number one is the product interface. This is the contract. It's the rulebook. In our payment example, we'd have an interface called payment method, with maybe just one method, pay. Now, any part of your code that uses a payment method, like your checkout service, will only ever know about this interface. It has absolutely no idea if it's holding a credit card or an Apple Pay object. This is a big deal. It's called the dependency inversion principle. You depend on the abstract rules, not the messy concrete details. Next up, you have the concrete implementations. These are the actual structs that do the real work. So we might have a cash PM struct and a debit card PM struct. And this right here is where Go's design is just so beautiful. As long as both of these structs have a pay method that matches the interface, they automatically fulfill the contract. There's no implements keyword you have to add. It just works. It's incredibly clean. And finally, we get to the third pillar, the factory function itself. This is the heart of the whole pattern. Its job is actually pretty simple. It takes in some kind of identifier, like a number or a string. It uses a switch statement to figure out which type to create. It makes a new instance of that type. And then, and this is the most important part, it returns that instance as the abstract interface, completely hiding the real type from whoever called it. Now, look really closely at this function signature. See how it returns two things? It returns the payment method interface, which is what we want, but it also returns an error. This is absolutely critical. The code that calls this function gets the object it needs, but the Go compiler also forces it to deal with the possibility that something went wrong. What if you ask for a payment method that doesn't exist? And that brings us to a point that you just can't ignore. Returning an error isn't just a nice to have, it is essential for writing code that doesn't blow up in production. A factory that just quietly returns nil when it gets confused is a ticking time bomb, just waiting to cause a nil pointer panic. This product error pattern is standard, idiomatic Go for a very good reason. It helps you build robust, predictable software. Okay, so we've seen all the pieces. We've built our factory. Now for the real payoff. This is that aha moment, where you see just how powerful this design is when it comes to handling change. So imagine this is the line in our factory that creates our debit card processor. It's working fine, it's been in production for months, everything's great. But now the business tells us we're migrating to a brand new, way better third-party debit card system. And there's the change. We write our new struct, new debit card PM, making sure it satisfies the payment interface. Then we go into our factory and we change this one single line of code. That's it. The entire system upgrade is contained right here in this one spot.
And the result? It's incredible. Not one single line of code in our checkout service or our reporting tools or any of our tests needed to be touched. They are completely oblivious that a massive underlying change just happened. The factory absorbed all of that complexity. That right there is the superpower of this pattern.
Now, that switch statement is pretty good. It's simple, it's easy to read, but we can do even better. It has one tiny flaw. Let's look at how we can build a system that's so extensible you almost never have to modify it again.
So there's this really important idea in software design called the open/closed principle. It basically says your code should be open for extension, meaning you can add new functionality, but closed for modification. Our switch statement kind of violates this because every time we want to add a new payment type, we have to go back and physically change the factory function by adding a new case. The solution is a more advanced approach called the registry pattern. It's brilliant. Instead of a switch, the factory uses a map. The map's keys are the payment type identifiers, and the values are functions that know how to create that specific payment type. Now, when you create a new payment type in its own package, it can have an init function that automatically adds its creator function to the central map. The factory code itself, it never, ever changes.
And if you think this is some obscure academic idea, I promise you it's not. You've already used it. If you've ever worked with databases in Go, you've seen it in action. You just add that blank import for the Postgres driver, import_github.com/lib/pq, and it just works. How? That driver's init function registers itself with the main database/SQL package. The SQL.open function is just a factory using this exact registry pattern.
All right, that was a pretty deep dive. So let's just boil it all down and quickly recap the absolute most important things you should walk away with. First, the whole point of a factory is to hide the messy details of creating objects. By returning an interface, it lets the rest of your code work with general concepts instead of specific concrete types. This is what we mean by loose coupling. Second, never forget how awesome Go's implicit interfaces are. They make this pattern incredibly clean. You can invent brand new payment types, and as long as they have the right methods, all your existing code will just accept them, no questions asked. And third, please, please always build your factories to be safe. That product error return signature isn't optional. It's the proper idiomatic Go way to prevent those horrible nil pointer crashes that always seem to happen at 3 a.m. So I'll leave you with this question to think about. Now that you know what to look for, take a look at your own projects. Where do you have a giant switch statement or a long chain of if-else blocks that are just creating different kinds of things? Where does it feel painful to add a new feature? That is probably the perfect place to refactor and introduce a factory.